Okay guys, this is another video where we're going to look at a real exam question and basically go through and give you the model answer. So picked a few topics again, they're all from C1 and C2, but they are questions that come up year after year after year. So if you understand this question, there's good odds it comes up or something similar comes up in your year. So this question is all about group 1 elements. So let's read the first bit of the question. What we do in the first half of the video is just talk you through the questions and give you some key ideas. I'll then put a pause in where you can have a go yourself, and then I'll model the answer. I'll probably get a bit of paper so it's a bit clearer, because I know there's a lot of glare on my board. So, sodium is a group 1 element. A small piece of sodium is added to some water containing a universal indicator. Describe what you would see. Key things I've been told, it's a group 1 element. So hopefully in your brain, oh yeah, I remember those at school, alkali metals, they do a particular reaction with water. It is a recall question. If you cannot remember that reaction, you are going to be a bit stuck. So there isn't much in chemistry that you actually have to remember. A lot of it is about recognizing patterns and applying rules, but there is some recall stuff, and group 1 metals are definitely one of them. So if you can't remember those, might be worth watching a video perhaps of the group 1 metal reactions. We're told that we're using sodium, and there's a universal indicator in there. That's important. So clearly one of my observations is probably going to be with the colour change because of universal indicator. And the key word, we're being asked to describe. So importantly, we're not being asked to explain. We're not being asked to say why things happen. We're just being asked to describe what actually happens. So it is recall. It is a simpler level of learning. So that will be 3 marks. Key things, group 1, we've got some UI in there, and we're describing, not explaining. Okay, the second bit is a balancing an equation. There is always going to be a couple of those in your exam. This is a classic. If you don't have balanced equations, I have done a whole video about balanced equations, which might be worth seeing. There's not much more I can sort of tell you about that to prepare you, other than about that you need to balance it. They do try and help you a little bit, so notice what have we been told already? So we've given the chemical formulas. We haven't got to mess around with those. We are just going to put numbers to balance it. So the only place numbers can go are in front of things, and we are missing a chemical. So in that spot there is something else we're going to make. So there's a bit of recall there about remembering what it is you make when you do the alkali metals of water, and the fact that your UIs change colour is a bit of a hint as well. Finally then, this is then the longer answer bit of it. We are told francium is the most reactive element. We're going to explain why in terms of our electronic structure. So at this point you'd actually look at the periodic table, and you'd see that as you go down the periodic table, in group 1 it starts with lithium, and the one at the bottom is francium. Okay, so there's going to be some sort of link to the periodic table and why it is that they get more reactive going down. That is a question that virtually comes up every year. So that question is all about explaining that pattern. In this case we're using francium as an example, but we've got to talk about electronic structure, and of course periodic table tells us something about electronic structure. So they're all in group 1, so they all have something in common. They all have one electron in their outer shell, but clearly the electronic structure is going to be different in another way. Right, giving you a bit of setup for those questions. You've got 8 marks in total. So in a real exam, if you budget yourself about 8 minutes, you'd be looking good. Have a go. Pause the video now. See you do. Talk to you in a minute. Okay, so hopefully you've had a go at answering these yourselves. Let's just talk you through how I would have answered them. So let's remind ourselves about this first bit. We've got sodium and it's water, and our key sort of command word there, what we've got to do, we are describing. Okay, and we know we've been told we've got universal indicator, so that's probably going to be important too. It's 3 marks, so I probably need to make 3 specific points. So first one I'm going to make, I know that I've got universal indicator. I know they're called the alkali metals. When you put them in, one of the things you create is something called a hydroxide. So in this case, you'd mix sodium hydroxide. Hydroxides are alkaline, so they would turn universal indicator purple. So you need to remember, A, that we make an alkaline solution when you react alkali metals with water, and B, that changes the colour of UI from green if it's in neutral water to purple. So I'm not going to explain why, I've just got to describe why. So what's actually happening, I would say, the universal indicator solution. It's a solution because obviously it's mostly water. It's just got a little bit of UI in there. Turns from green to purple. Okay, that's definitely giving me 1 mark. Okay, I can then make, basically, there's lots of things I could say. I need to make 3 distinct different points. So, there's lots to choose from. I don't know what I'm going to say. One of the weird things about the alkali metals is they have quite low densities. They actually float on water. So, I'm going to say that the sodium floats on the water. It also moves around as well. As it's reacting, it tends to move around the on the surface of the water. The other one that's I'm going to make, so it floats in the water. I know that when it reacts, it creates a gas, because that makes a flammable gas, which is something I could say. So I think my easiest one to say, the sodium fizzes. Because the visual sign you get of making a gas is you see it fizzes. There are other points I could make. So I could say that if I set fire to it, I get a yellow flame, because the gas that you're giving off will burn. I could say that the piece of sodium, as it reacts, gets smaller during the reaction. All of these are relevant observations, so you don't have to have made the 3 points I've made, but those are the 3 I've chosen to make. Okay, the next bit, balancing equation, 2 marks. Typically how these are marked, you get 1 mark for identifying all the right chemicals. So I've already got 3, so I'm going to get 1 mark probably for identifying the chemical that hasn't been given to me. You then probably get the 2nd mark for the actual balancing. So what do I make in this case? Sodium plus water, I make this chemical called sodium hydroxide. So you really need to remember that all alkali metals, when you react them with water, you make this thing called a whatever metal hydroxide. So lithium would make lithium hydroxide, sodium in this case makes sodium hydroxide. So formula for sodium hydroxide is Na, 1 atom sodium, OH. So it's bonded to an O and H. That O and H together is called hydroxide. I've probably got 1 of my 2 marks now. That's really probably from memory, or you might have worked it out from what elements perhaps you had on this side and needed on this side. Now I need to balance it. So they've been a bit nice in the sense that they've given me some lines to show me where perhaps I might need numbers. If I do this from sort of real base principles, on this side of my equation at the moment I've got 1, 2, 3 hydrogens. On this side I only have 2, so I'm going to need some more. So if in doubt, it's normally going to start with 2. If I put a 2 there, that's now giving me a total of 2 times 2 hydrogens, which is 4 on this side. But I've only got 3 on this side, so how can I get another 1 on this side? Well, if I put a number there that's going to give me 2 more, that won't help. They also haven't given me a line there, so they may be indicating I don't need a number there. But if I put a 2 there, that does give me 2 hydrogens here. So 2 hydrogens and the 2 in there is a total of 4. 4 on this side, 4 on this side. So that works. 2 oxygens on this side and 2 oxygens on this side. That works. That's looking good. 2 sodium on this side, but only 1 over here. So logically, I need a 2 there. So you end up having a 2, a 2, a 2, and nothing in front of the hydrogen gas. So 1 mark if you put in NaOH. A 2nd mark if you then successfully balance it. In this case, it is all the 2s. Obviously, any other element in group 1 would balance just the same. Right, the last bit of the question then. So this part of the question is 3 marks. Often, actually, this mark you get this section of this question can be worth potentially up to 6 marks, just depending on how much detail you want. So only 3 marks on this one, but we'll talk it all through. And so if you did get higher mark one, you'd be good for that too. So francium is the most reactive element in group 1. Explain why in terms of electron extraction. So I'm going to do a little drawing at the bottom here. I probably wouldn't do this in exam, but just to help you guys explain. So there's francium, here's lithium. And notice I've drawn francium much bigger. Reason being, francium is further down the group, and in group 1, the further you go down, the more reactive they're getting, but they're getting bigger because although they've all got 1 electron in the outer shell, you're getting more and more shells as you go down the periods. Therefore, francium is going to have lots and lots of shells before you get to the outer shell. Lithium, in fact, only has 2, so inner shell and then the outer shell. So this distance from the positive nucleus to the negative electron, remember that's what holds the electron in place, is an electrostatic force between positive and negative. It's getting further and further away, and that attraction is getting less and less, which means that electron can be lost more easily. If you can lose your electron, that's what you're trying to, all these metals are trying to do in a reaction, you're going to be more reactive. So that's my description. We now need to kind of put that into words. So to get our 3 marks, how would we do that? I'll probably start with this idea of size. So I'm going to say francium
is the largest of the alkali metals. And importantly, we're going to say, if it's bigger, this means the attraction between its outer shell electron and the positive nucleus is weaker. So I've probably got 2 marks here. I've said pointing out about 2 size, francium is bigger, and I've said that because of that, the attraction of that electron to hold it in place, to hold it as part of the atom, to not be lost in the reaction, is getting weaker. All I really need to now say is that because that attraction is weaker, that electron can be lost more easily. So all I'm going to write is exactly that. This means the attraction between the outer shell electron and the positive is weaker, therefore it can lose that electron more easily, which is what makes it more reactive. So, it's not an easy question, that one, but in theory you could have a question that was worth more marks than that, and it's the same ideas. Key points: it's bigger. Bigger means more shells. Outer electrons further out, it can get lost more easily. Brilliant, guys. Thanks for your time on that. Hopefully you've gone through that with me and you've scored most of the marks yourself. We'll be doing a few more of these videos. Dr. York will do a few as well. We're going to focus on C1 and C2, but all of these are real exam questions, and most of them are ones that do come up year after year in different guises. So I hope that's been helpful. I'll talk to you soon. Bye now.